Okay, so our next question on Bayes theorem is, this question was asked in GATE 2014. The problem is, in a given rainy season, it may rain 70% of the time. If it rains, then chance that a village fair will make a loss on that day is 80%. However, if it does not rain, then chance that village fair will make a loss is only 10%. Now it is given that if the fair has not made a loss, then find the probability that it has not rained on that day. So again, this is a problem of Bayes theorem, and we have to solve this problem using tree diagram. So see, there are two possibilities. One is that it will rain, and the other possibility is that it will not rain. So I'm going to draw two arrows. Probability that it will rain is 70%, so this means 0.70. It is given that it may rain 70% of the time. So probability that it will rain is 0.70. And probability that it will not rain, so I'm writing this as R complement. R means rain, so R complement means it will not rain. So this is 0.30. Okay, R complement, this will be 1 minus probability of R. Probability of R is 0.70, so probability of R complement, this will be 0.30. Now the question is, if it rains, then chance that village fair will make a loss on that day is 80%. So if it rains, then in that case, there are two possibilities. Either the fair will make loss or it will not make loss. So probability that it will make a loss, this is given, this is 80%, so 0.80. And probability that it will not make a loss, this will be 1 minus 0.80, so this will be 0.80. So these are the two possibilities when it rains. And however, if it does not rain, then in that case the village fair will make a loss is only 10%. So if it does not rain, then in that case the probability of making a loss is 0.10. So this means probability of not making loss, this will be 1 minus 0.10, so 0.90. Now we have to draw these lines, and on these lines we have to multiply these numbers. So if I multiply 0.70 with 0.80, I will get 0.56. If I multiply these two numbers, I will get 0.14. 0.3 into 0.1, so this will be 0.03. And 0.3 into 0.90, so this will be 0.27. Now the question is, it is given that the fair has not made a loss. So these two terms are representing L complement. Okay, this one is not making a loss when it has rained, and this term is representing not making a loss when it has not rained. So these two terms are representing not making loss. Now the question is, we have to find the probability. It is given that it has not rained, so this means it is given that it has not rained, so this means, sorry, it is given that the fair has not made a loss, so this means it is known that the fair has not made a loss. Now the question is, find the probability that it has not rained. So this means we have to find this quantity. It is given that the fair has not made loss, so L complement. Now we have to find what is the probability that it has not rained. So we have to find R complement given that this event L complement has occurred. So R complement, this will represent your term 0.27. Okay, this will be the probability that it has not made, the fair has not made a loss when it has not rained. So in denominator I have to write probability of not making loss. So this first term is probability of not making a loss when it has rained, so this will be 0.14, plus the second term will be 0.27. And in numerator we have to write, since we have to find what is the probability that it has not rained, so this means we have to write this term 0.27 in numerator. So this will be 0.27. Now if you multiply by 100, you will get 27, and this divided by 27 plus 41. 27 plus 14, 41. So your correct answer is option D. Now again, these are very simple problem. Once you know how to draw this tree diagram, then you can solve any problem of Bayes theorem or total probability using this tree diagram. So this was the end of first part of this chapter, probability. Now after this, we'll talk about random experiment and we'll see different type of distributions. Okay. Okay, so our next topic is random variable. Now the purpose of random variable is that it associates real number to the outcome of sample space. So for example, if we are tossing two coins, so in that case our sample space will be head head, head tail, tail head and tail tail. Now suppose let x be the number of heads Okay, so suppose if x is representing number of head, then with each outcome you can associate some real numbers. If the outcome is say 2 head, so for this particular outcome the value of x will be 2. If the outcome is say head tail, then here the value of x is 1. Similarly for tail head, again the value of x is 1. And if the outcome is 2 tail, then the value of x will be 0. So this x is nothing but random variable. X, which is representing number of head in this particular example, is the random variable. Now see, there are two types of random variable. The first type is, there are basically two types of random variables. So the first one is discrete random variable. Now discrete random variable means that only discrete value of x is possible. For example, here if you consider as x as the number of head, then only possible value of x is x will be either 0 or 1 or 2. So here we have some discrete value of x. No value of x is possible between 0 and 1. Either you will get 0 head or 1 head or 2 head. So therefore this x, which is representing number of head in tossing of 2 coin, this is an example of discrete random variable. Now the second type of random variable is continuous random variable. Now with the help of one example, we will see the meaning of this continuous random variable. So suppose if I have a circle and say the radius of this circle is given. Suppose I have this circle and the radius of this circle is say r unit. Now our experiment is that we are randomly selecting any point inside this circle. So suppose if the point is say this point, we are selecting randomly any point inside the circle. Now x is the distance of selected point. X is distance of selected point from center of circle. So now in this case, suppose if the point selected P is here, so in this case this will be your distance x. So x is representing the distance of selected point from the center of circle. Center is at origin, so this distance is say small x. Now here the value of x, which is representing distance of any randomly selected point inside the circle from the center of the circle, this will be an example of continuous random variable, because here all the value of x is possible. Here the possible value of x is, if you are selecting center, then the minimum value of x will be 0. And if you select a point on the circumference of the circle, then in that case the maximum value of the radius will be, maximum value of x will be r. So here all the value of x between 0 and r is possible. For example, if suppose the radius is say 2 unit, so in that case the value of x will be between 0 and 2, and all the values which are between 0 and 2 is possible in this particular example. So therefore this x, which is representing distance of any selected point from the center of circle, this will be an example of continuous random variable. So first thing, the purpose of random variable is that with each outcome you can associate some real numbers. If we are tossing 2 coins and x is representing number of head, then these are the possible value of x, either 0 or 1 or 2. There are two types of random variable, discrete and continuous. The first one is an example of discrete random variable, where the second one is an example of continuous random variable. So after this we will see what is probability distribution table and probability density function. So our next topic is probability distribution table. Now first thing, this probability distribution table is made for discrete random variable. We have seen in our earlier discussion that there are two types of random variable. One is discrete random variable, another is continuous random variable. So this probability distribution table is defined for discrete random variable. Now let me explain the idea of this probability distribution table with the help of one basic example. So suppose if we are tossing 2 coins, so in that case our sample space will be, these are the 4 possible outcome: head head, head tail, tail head and tail tail. So these are the 4 possible outcome. Now suppose if x is the random variable which represents number of head in tossing 2 coins. So with each outcome you can associate some value of x. If the outcome is 2 head, then in this case x will be 2. If outcome is 1 head 1 tail, x will be 1. Similarly for this outcome also x is 1. And if the outcome is 2 tail, then it means x is 0. So these are the 3 values of x. X will be either 0 or 1 or 2. Now in probability distribution table what we do, that we make one table, and in the first row we will write the different value of x. So here there are 3 possible value of x. X will be either 0 or 1 or 2. So in the first row I will write the different values of x. These are the possible values of x, 0, 1 or 2. And in the second row, I will write the corresponding probability. So here I should write what should be the probability that x is equal to 0. Now x is equal to 0, this means the outcome is 2 tails. So this is the favorable case, and total there are 4 possibility. Okay, you can easily see that in this sample space there are 4 elements, out of which one is favorable element. So this means probability that you will get 2 tail, this will be simply 1 by 4. Similarly, the probability that x is 1, now x is 1 in these two cases, either head tail or tail head. So this means there are 2 favorable outcome, these 2, and total number of outcome is 4. So this means the probability that x is equal to 1, which means the probability that we are getting exactly 1 head, this will be 2 by 4. And finally, probability that x is equal to 2, this means the outcome has to be 2 head. So here the probability that x is equal to 2, this will be again 1 by 4. Favorable outcome 2 head, total number of outcome 4, so 1 by 4. Now this is nothing but probability distribution table of x, which is representing number of head in tossing 2 coins. We write values of x and their corresponding probability, and this table is called probability distribution table. Now this was one special case. The general form of probability distribution table will be that we will have x, different values of x in first row, and the corresponding probability in second row. So here I will write the value of x, and here the corresponding probability of x. So say the value of x is x1 with probability p1, the value of x is x2 with probability p2, x is x3 with probability p3, and in this way the last value of x is say xn and the probability is pn. So this will be the general format of probability distribution table. These are the different possible value of x, and these are their corresponding probability. Now one of the very important result of this probability distribution table is that if you add all these numbers, if you add p1 plus p2 plus p3 up to pn, this is the sum of probability of different values of x. So this is always 1. Now this result is very, very important. You can write this result in summation form also, that summation pi, this will be 1, I is from 1 to n. So this formula is this you can verify here also. For example, if x was number of head, then these are the 3 possible value of x, and these are their corresponding probability. Now if I add these numbers, 1 by 4 plus 2 by 4 plus 1 by 4, then I will get 1. So this is very important result. Now we will take one problem and we'll see how to apply this formula. So the question that we have is, a random variable has following probability distribution. Now the value of x and their corresponding probability is given. These are the 7 possible value of x from 1 to 7, and in the second row we have their corresponding probability. Now this question has 2 parts. The first part of the problem is we have to find what is the probability that x is equal to 1. Now you can easily see that the probability that x is equal to 1 is k. So basically we have to find this number k. Once we know k, then probability that x will be 1, this will be simply k. And the second part of the problem is what is the probability that x is greater than 2. So x is greater than 2, this will mean x is 3 or 4 or 5 or 6 or 7. So we'll see how to solve that problem. First we should calculate this k. So in order to calculate the value of k, we are going to use this property that sum of all these probability, k plus 2k plus 3k up to 7k square plus k, this will be 1. So summation pi, this will be 1. This means k plus 2k plus 3k plus 2k plus 2k square plus k square plus 7k square plus k, this will be 1. Now if you add all these, then 7k square plus 2k square plus k square, you will get 10k square. Similarly you will get plus 9k minus 1, this equals to 0. Now if you solve this quadratic equation using factorization method, this you can do on your own. So the value of k that you will get, this will be minus 1. You can easily see that minus 1 will satisfy this equation. 10 minus 9 minus 1, 0, and 1 by 10. So these are the 2 possible value of k. Now obviously this k equals to minus 1 is not acceptable because probability cannot be negative. Probability that x is 1 is k. So k cannot be negative, therefore only acceptable value is 1 by 10. Now the first part of the problem is we have to find probability that x is equal to 1. So from the table you can see that this will be k and the value of k is 1 by 10. So the answer to first part of the problem is 1 by 10. And the second part of the problem is we have to find what is the probability that x is more than 2. So probability that x is more than 2, this we can write. See, sum of all these probability, this will be 1. So x more than 2, this means 3 plus 4. Maybe I should write this thing here. This will be probability that x is equal to 3 plus probability that x is equal to 4 up to probability that x is equal to 7. Now this thing you can write as 1 minus probability that x is equal to 1. Okay, if I subtract this x equals to 1 and 2 from the total, then I will get the required probability. So probability that x is equal to 1 plus next term probability that x is equal to 2. Now this will be 1 minus, you can see that probability is x is equal to 1, this is k. So I will get k from here and 2k from here. Now this will be 1 minus 3k, and if you substitute the value of k as 1 by 10, then this number you will get is 0.7. So probability that x is equal to 1 is 1 by 10 or 0.1, and probability that x is greater than 2 is 0.7. So this was all about this probability distribution table. Next we will talk about probability density function. Okay, so our next topic is probability density function. Now this probability density function is defined for continuous random variable. We have seen in our earlier discussion that probability distribution table is defined for discrete random variable. Now in case of continuous random variable, we define something called probability density function. Now the definition of probability density function is a function y equals to f of x is called probability density function if. Now there are three conditions that the function must satisfy in order for it to be classified as probability density function. So the first condition is that fx has to be a positive function. Fx is greater than equal to 0 for all x belonging to some real number. So fx is always positive whatever be the value of x. This is the first condition. The second condition is that probability that x is from a to b, probability that x is from a to b, this is given by the formula integration a to b fx dx. So this is the second condition. The first condition, fx is always positive. Second, if fx is probability density function, then integration a to b fx dx, this will give you the probability that x is from a to b. And the third part is that the value of integral from minus infinity to infinity fx dx. Now say this will mean nothing but the probability that x is from minus infinity to plus infinity. Okay, integration a to b fx dx, this will give you the probability that x is from a to b. So integral from minus infinity to infinity fx dx, this will give you the probability that x is from minus infinity to plus infinity. Now that probability obviously will be 1. So therefore the value of this integral is 1. Now this result is very, very important. In GATE also they have asked question on this formula on a number of occasions. So if fx is probability density function, then it will always satisfy these three conditions. Fx is always positive. The value of integral from a to b fx dx, this will be nothing but the probability that x is from a to b. And finally the integral from minus infinity to infinity fx dx, this will be 1. See, in case of continuous random variable, we cannot draw that probability distribution table. The reason is that in case of continuous random variable, we will have infinitely many possible value of x. Okay, in case of discrete random variable, only some finite value of x is possible. For example, if we were tossing two coins and x was representing number of head, so in that case only three value of x was possible. Either x is 0 or 1 or 2. But in case of continuous random variable, infinite value of x is possible. So here we cannot draw probability distribution function. So in case of continuous random variable, we define probability density function. Now these are the properties of probability density function that you should remember. Now the first question is, a continuous random variable has following probability density function. It is given that fx is lambda into e to the power minus x by 100 if x is positive and 0 if x is negative. Now the question is, we have to find the value of this lambda. Now similar question has been asked in GATE and engineering services. So this is very simple problem. You have to apply this third property. If fx is probability density function, then it means that integral from minus infinity to infinity fx dx, this will be 1. Now using this relation, you have to find the value of lambda. So see, I can break this integral from minus infinity to 0 fx dx plus integration 0 to infinity fx dx. Now you can see that when x is Negative, meaning that when x is from minus infinity to 0, the value of fx is 0. So if I substitute 0 in place of fx, this term will become 0. So basically we have this relation, integration 0 to infinity fx dx, this will be 1. Now I can write this relation as integration 0 to infinity. When x is positive, then in place of fx you have lambda into e to the power minus x by 100, and this will be 1. Now using this equation you have to find the value of lambda. So I can write this as lambda e to the power minus x by 100, this divided by minus 1 by 100, limit from 0 to infinity, this will be 1. Now see, in order to avoid any calculation mistake, you should change the sign, minus sign to plus, and also change the limit of integration. So I will write this as infinity to 0. Okay, we know that integration a to b fx dx is minus integration b to a fx dx. So here I have changed the minus to plus sign, and I have reversed the limit of integration from 0 to infinity to 0. Now I can write this relation as, I will get 100 into lambda e to the power, if I place x equals to 0, I will get e to the power 0. If I place infinity, I will get minus infinity. This is 1. Now we all know that the value of e to the power minus infinity, this will be 0. E to the power minus infinity will be 1 by e to the power infinity, 1 by infinity 0. So, and the value of e to the power 0, this will be 1. So basically 100 lambda multiplied by 1 minus 0, this will be 1. So finally we will get lambda equals to 1 by 100. So this was very simple problem. Once you know the definition of probability density function, then you can easily solve these type of problems. So we'll take some more example on this probability density function.